Hello everyone, I am Mr. DHAKSHUNHAAMOORTHY, Assistant Professor, Department of Artificial Intelligence and Machine Learning. I am handling subject 22 CS 302 Computer Organization and Architecture. Unit 1 Computer Fundamentals. In this unit, we are covering a topic addressing modes. Generally, addressing modes are classified into 12 types. These addressing modes are mainly used to access the operands from memory in 12 different ways. First one is implied or implicit addressing mode. Second one, stack addressing mode. Third one, immediate addressing mode. Fourth one, direct addressing mode. Fifth one, indirect addressing mode. Sixth one, register direct addressing mode. Seventh one, register indirect addressing mode, relative addressing mode, indexed addressing mode. 10th one, base register addressing mode. 11th one, auto increment addressing mode and auto decrement addressing mode. Mainly direct and indirect addressing mode for memory and registers, and few more relevant things are there. One is auto increment and auto decrement, and register direct and register indirect, memory direct addressing mode, memory indirect addressing mode. We will see in detail in next slides. Implied addressing mode. In this addressing mode, the definition of the instruction itself specifies the operands implicitly. It is called implicit addressing mode. For example, the instruction complement accumulator is an implied mode instruction. We are not giving any operand to the instruction. Zero address instructions are implied mode instructions. Stack addressing mode. In this addressing mode, the operand is contained at the top of the stack. We are using push and pop operations for getting two operands from the stack for storing the result into the stack. So mainly we can take one example for addition instruction. The instruction simply pops out two symbols contained at the top of the stack. The addition of those two operands is performed. The result so obtained after addition is pushed again at the top of the stack. Third addressing mode, immediate addressing mode. In this addressing mode, the operand is specified in the instruction explicitly instead of address field. An operand field is present that contain the operand. For example, add 10 will increment the value stored in the accumulator by value 10. Or move a register, hash 20 initializes the register R to the constant value 20. Direct addressing mode. In this addressing mode, the address field of the instruction contains the effective address of the operand. Only one reference to memory is required to fetch the operand. It is also called as absolute addressing mode. Here in this example, we can get some idea. Here the instruction contains opcode and operand. The operand portion we are mentioning accumulator register. It gives the address of the operand directly to the memory address. And add x will increment the value stored in the accumulator by the value stored at memory location x. It can be denoted accumulator gives accumulator plus the content of the memory. indirect addressing mode. In this addressing mode, the address field of the instruction specifies the address of memory location that contains the effective address of the operand. Two references to memory are required to fetch the operand. Here in this instruction, the same way, the memory content or data is fetched indirectly from the memory. Here, first of all, we are giving reference to the memory address. Once we are referring that particular memory address from which we are getting the address for the main content. So here we are accessing the operand indirectly. Example, add x will increment the value stored in the accumulator by the value stored at memory location specified by x. It is denoted accumulator gives accumulator plus the address of content indirectly mentioned. That is why we are representing double square bracket for the particular memory content. A register direct addressing mode. In this addressing mode, the operand is contained in a register set. The address field of the instruction refers to a computer register that contains the operand. No reference to memory is required to fetch the operand. Here the instruction in which operand portion, some register we are using. This register gives address of the particular operand memory location. Example, add R will increment the value stored in the accumulator by the content of the register R. It is denoted accumulator gives accumulator plus the content of memory which is accessed by the address mentioned in the register. Register indirect addressing mode. In this addressing mode, the address field of the instruction refers to a CPU register that contains the effective address of the operand. Only one reference to memory is required to fetch the operand. Here in this diagram, operand portion, we are using register which is giving the address for the register set, and that the effective address through which we are accessing the operand from the memory. Here, indirect way, by the support of registers we are getting, that is why indirect register addressing mode. Example, address R will increment the value stored in the accumulator by the content of memory location specified in register R. Is accumulator gives accumulator plus a register reference address which denotes the operand value from the memory. A relative addressing mode. In this addressing mode, effective address of the operand is obtained by the adding the content of the program counter with the address of the instruction. Effective address equal to content of program counter plus address part of the instruction. Here the instruction contains operand and opcode. The operand portion we are using accumulator value added with the program counter value, then we are getting effective address. From the effective address we are accessing operand from the memory. Indexed addressing mode. In this addressing mode, the effective address of the operand is obtained by adding content of the index register with the